Hello, everyone. Thank you so much for joining for this webinar. I would request all the panelists to please switch on their cameras. Hello, everyone. Yes. So I'll introduce our speaker for the day, Anand Rao.
Hey.
Yes. Anand is a senior technical instructor and a cloud consultant. He has worked with large enterprises for about 15 years and has a wide range of technologies in his portfolio. Anand has also delivered instructor-led training in several states in India, as well as several countries like the USA, Bahrain, Kenya, and UAE. He's worked as a Microsoft certified trainer globally for corporate major clients. Thank you so much, Anand, for getting on board for this webinar. Over to you.
You're welcome. All right, so let's get started. The hour, right? We are all surrounded by buzzwords these days. They're all around us, and in IT, we are all especially prone to using those buzzwords. We fall in love with new technology, love with new frameworks, architectures, tools, you name it. Deep inside, we got all geeks, and it's not a bad thing. I'm just saying that every idea that at some point becomes a buzzword. And it is how the world is fueled by marketing. And that's how it works. And every technology is a buzzword at some point, and it gains traction and traction, and people start to talk about it. And today we are here, we got together to talk about containers and Kubernetes. And we know that that's not the only thing in this world. The world is driven by several other buzzwords that we have. Think about blockchain, think about artificial intelligence that's being overly used in everything. um, think about artificial intelligence or machine learning as too many things going on in today's world, right? So I hope you are able to see my screen. Are you able to see the PPT? Okay, screen two, share. Okay. Yep. Here we go. All right. Okay, now I've got the full screen here. Okay, so as you already know, the crux of today's discussion, it's all about containers and Kubernetes, but my core strength and that where I started from is mostly identity and access management, Active Directory, Novell directories, Oracle directories, migration using different tools, and then slowly cloud bumped up to my career. Back in 2011, I started with Microsoft Azure, AWS, and slowly Google Cloud also came into my portfolio. So I had to continuously learn about technology and the way things are moving forward. Otherwise, it's very quick to get outdated, isn't it? All right, so that's about me. We talk about containers, and no demonstration is completed without labs. So we're going to do labs on both containers and Kubernetes. So you'll understand why containers, why did we move away from the virtualization model, and why is a need for Kubernetes, right, at the end of it. And we'll also do the touch up on the lab for Kubernetes. Remember that it's a level 101, primarily because we don't know the audience yet. We got, I don't know the perfect number, but um, looks like about 200 plus people here today, possibly. And there may be people who just started their career, maybe 20 years experience. And I was just reading some of the chat. It said that people have already worked on the dev and prod environments in Kubernetes. So probably for them, it's going to be a refresher. But the objective here is to start from the very basics to give you all an idea of where are we going when it comes to application hosting or hosting your web applications, making sure that the applications are available, they are secure in that nature. Okay, so that's what we think of when we think about containers, isn't it? So we think about containers that are being loaded and they go from point A to point B, an array of containers that are being pumped into a ship and that goes from, let's say, a destination A to destination B, right? That's what we think about when we say containers. But when it comes to information technology, it is almost the same, and there is an analogy that we can use. And the usage of this container terminology is not just like that. There is a reason for this. The reason is that if you look at these containers very closely, they are meant for a purpose. There is a reason why there's a container, right? These containers are isolated. That means the content of one container cannot get into the container number two or number three or whatever, right? They are totally isolated. There is no way data can go from, when you say data, it is the objects that they can go from one container to another container, the red container to the blue container, or from blue to green, right? They're totally isolated, but they are all tied up together to do a particular activity, right? Now, when it comes to information technology, it's almost the same thing, but here we say that you will be hosting applications. Now, we are all coming from virtualization world, right? And before that, there was physical infrastructure. Applications were hosted on a physical box. So that means that you had to install the operating system on top of that and then take care of all those physical servers. Back in the year 2000 and probably around that era, the concept of virtualization came in, and a lot of companies started to absorb the information that's provided by giants like VMware, and Microsoft slowly started to pick up as well, and they got in Hyper-V, and then Oracle. They said, okay, Citrix, and as well as Oracle Zen Server. Virtual boxes were created, and there are several vendors in that space of virtualization. Well, people who are new to virtualization, I would just say that if you got in a hardware, you're creating another layer on top of it to create virtual machines. What I have in front of me is a small Lego box. If you look at the video carefully, this is a Lego box, right? So I thought I'll use these props to give you an explanation of how the virtualization looks like if it's totally new to you. So I made this Lego and it is a box, right? Consider this as a hardware, right? This is a hardware. And on top of this hardware, what you usually do in terms of virtualization world is you create another layer. And let's consider this yellow box as the virtualization layer, right? So you got this hardware, you procured it from, let's say, Dell, HP, IBM, whoever, and then you contacted VMware, and VMware gave you the license for ESXi, right? That's installed here, right? And now your job is to create virtual machines. So what you do is you go ahead and start installing virtual machines on top of it, right? So this brown thing that you see is the virtual machine. That virtual machine has an operating system. So the yellow thing is an operating system, let's say Linux, Windows, whatever. And on top of it, let's say you want to install an application. An application could be anything, a .NET based application, or Apache Tomcat based application, anything, right? For that application to work properly, you need to have dependencies installed. So I will have first .NET install if it's a .NET based application, right? So if the application needs .NET 3.5 or .NET 4.0, you will install that dependency. Let's say this pink color Lego is dependency. Once that dependency is successfully installed, what you do is you install that application, right? So that completes the entire stack. So you got the hardware stack, then you got the virtualization stack, which we also call as the hypervisor, as you also see in the presentation. That's on the which side? On the right hand side, you see the infrastructure and the hypervisor. The underlying hardware is forming your infrastructure, and then top of it you got the hypervisor, and then you got all of those stacks. And I'm sure a lot of people here have experience creating virtual machines and can relate to what I'm saying, right? Now, in this entire stack, we got only one virtual machine running that application, but then you can have multiple applications running, and each application will have its own stack of operating system, of dependencies, and then finally the application, right? These virtual machines can be of different sizes. So if you see here, I've got another one here. This, so like this, you can go ahead and fill up your entire hardware stack. You know what I mean, right? So slowly over a period of time, you will have your hardware resources being pulled up by your virtual machines. At one point in time, the entire hardware will be sucked up by those virtual machines, right? So that's about the virtualization stack, right? That's about the virtualization stack. This is how we all used to work all of these times. And I've got another one here. Just a minute, I'll take care of this. Sorry about the interruption, guys. Um, so here we have an example for the people who are too new to virtualization, or somebody who's just trying to refresh what a virtualization concept could be. Just to iterate, this is a type 1 kind of hypervisor, right? So we have this yellow thing, which is the hypervisor in our case, and this type 1 because there's only one layer between the virtual machine and the hypervisor, and hence called type 1 hypervisor, right? Now, we moved away from this kind of a model to containerization, guys. And why did we do that? Is it only for the marketing sake, or do we just need to make applications? What I see is that we as IT enthusiasts make applications and different programs not for fun, but to add some value. We identify a problem, and that problem is solved by an application, right? It could be even hardware solve problems, right? So virtualization solved a particular problem. Containers is also solving a problem. The problem here is that if you look at the previous picture here, the application A really needs the dependencies, right? It needs the dependencies. So if you want to put this another application in the same virtual machine, well, most welcome, you can do that. But you need the dependencies for that as well. So application A has certain dependencies, application B has certain dependencies. There is a conflict. Sometimes the conflict happens between those dependencies as well. Dependencies sometimes do not coexist or do not like to coexist. And even if they coexist, there is a fight between the resources. Application A might demand certain resource, and application B has already consumed a whole lot of resource from the hardware, right? So there is a need to isolate those applications. There is a need to make sure that the dependencies are explicitly installed. They have their own room, and we are creating containers in order to ensure that the applications or softwares run reliably in their own environments, right? So when I say environments, it could be a separate container running a dev environment or a test environment, staging environment, etc., right? So we said that, okay, I really don't want to keep all my applications inside one single virtual machine. Instead, give them isolated areas like containers so that they can happily live, not together, but happily live in an isolated manner, right? So that's where containers came in. So how do you create containers? How do you ensure that containerization is created? Like, for example, you could create virtual machines with the help of hypervisors. Now, how do you create containers? You need a container engine. Now, in order to create a container engine, there were several vendors that came up and they said, hey, you use our tool and you will be able to create container. Just like the way you can create virtual machines with Hyper-V in Windows. You can create virtual machines with VMware ESX. There's Oracle VirtualBox. There's so many of them, production, non-production, depends on what you're doing. There are vendors out there. Similarly, in order to create containers, you can use, well, Docker is an example, but there are a lot of other vendors as well. Docker is most prominent one the organizations have picked up these days because of various features that it provides. But Docker was not the first one to containerize an application. In fact, it was Google who was the first one to containerize an application. And then it is also said that in the Linux world, containers were already existing in the form of C groups. It was already there, right? We just started to capitalize on that particular feature of Linux and made it a enterprise scale, business scale application that can be hosted on containers, right? So talking about Docker, again, I'm saying Docker is not the only container engine, is not the only one, but there are a lot of others. There's RKT, there is Mesos, there's DCOS as well. And of course, you can create containers with the help of Kubernetes, which will be the next one. But right now, just talking about containers, and then we'll advance towards Kubernetes. Okay, so that being said, let's go ahead and understand this. What are the benefits of containers? There's less overhead, there's increased portability. That means you can move containers from one box to another box. There is more consistent operation, greater efficiency, better application development. But reading these, I feel I missed a point here. And the main point is that if you want to host a web application that is, let's say, 100 MB in size, very small micro application, right? If you want to create such an application, what do you need? Well, you still need an entire operating system. Entire operating system means a full blown license of that operating system. And then you also need dependencies. An application called as calculator. So if you do a Windows R on your keyboard and type CALC, hit enter, you get a calculator. If you do Windows R on the keyboard, type notepad, hit enter, you get a notepad, right? Now, in order to host such small applications, you still need an entire Windows 10 box. A web application still needs a full-blown IIS or Apache. You need a full-blown operating system, right? You cannot go away with that. And the problem here is that in order to host an entire operating system, you need the relevant hardware as well, right? So just for 100 MB application, you need like gigabytes of memory, gigabytes of disk space as well. And that seems unfair because the application is small, it's tiny, 100 MB, and you're saying that I need gigabits of memory for what? Well, gigabits of memory for the operating system, gigabits of disk space for the operating system. And that's something not accepted. And that is another problem that containers are solving. Containers are saying that, well, you can host an application with minimal set of operating system. What does calculator.exe need? What does notepad.exe need? It needs maybe notepad.dll, another DLL, couple of executable files from your C Windows System 32. What does calc.exe need? Maybe a couple of DLLs, couple of INI files, etc. Maybe mathematics related DLL files or INI files from your C Windows System 32. What container says is that, well, you can go ahead and host that application and you need just that amount of the operating system, minimum set of libraries, minimum set of INI files, and that's all. You don't need to bring the entire C Windows System 32, entire Linux libraries for that application. Give me just what I want. And when you do that, the containers become lightweight. And because they become lightweight, they become portable as well. And that's where the second point comes in: increased portability. You can start and restart the service very quickly because you don't have to restart an entire operating system. You have to restart just that service, and it's very quick because the dependencies are less, right? And hence greater efficiency, right? Because that is quick, there are very less overheads, very less weight on that application. You're saying that you can develop an application better because your focus area is less, right? So these are the benefits of containers that you automatically get because containers are lightweight, right? Now, enough said. I'm strictly against theories. Unless we do a proof of this concept, the theory cannot be accepted. So let's go ahead and do that. And for the purposes of this demonstration, what I've done is a simple web application that exists here, which has the index.html. And there are a couple of supporting JPEG files, and there's a HTML file as well. So this is built locally. As you see, it's in my K drive and the Docker lab. It's there on the local folder, right? K drive inside the Docker lab folder. Now, if I open this up, what do I get? I just open this. Maybe it will open with Firefox, and Firefox will take a bit. Um, okay. All right. Okay. So that's that. It's taking its sweet time. Okay. So here it is. So there's some pictures. You can move left and right, and there are a couple of tabs as well on the top. So that's the basic web application. The idea is to go ahead and host it on, let's say, yeah, people are clapping. You can move left and right. There's some currency. There's some people. Yeah. So this is hosted on the local machine, and I would like to host it on where? On a container. Um, so let's go get started. So I'll close this. Okay. Now, in order to host this web application on a container platform, let's say Docker, I need to install Docker on my machine. And what I've done is that I've already installed it because there's no point showing installations in a webinar. It's like download it from the internet, do next, 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 and Docker gets installed. And there's nothing to configure. It's not a complex setup. So if I just go to Google and type Docker for Windows, you'll bump into a link, and then you can just click on Docker Desktop for Windows, and it downloads. Couple of seconds, and it will. It's a small file, 500 MB file. Is to hit next, 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 and it gets installed. Not a big deal. And if you're a Linux fan, you can do that as well. So what I'm going to do is just remove and say Docker for Linux, and there's one for Mac as well. So install Docker on Ubuntu. Lovely. There are other flavors as well. You can install on Fedora, Ubuntu, CentOS. I'm going to show you how to do that in CentOS in a few minutes. But so this Docker is already installed on my machine, right? There's not much that I need to worry about. Um, you can definitely check the version of Docker. So if I say Docker and hyphen version, hit enter, let's see what it shows me. Docker hyphen version, it's 20.10. It's the latest one. All right. What we will learn is how to build those Docker images. Now I'm using this new term, images. What is the image, guys? You guys are from the virtualization world and system engineering positions, so you would know what an image is, the difference between an image and a snapshot, right? Now, image is used to rebuild the virtual machine. So if I have an image of it and I need to build those virtual machines again and again, then I will just right click on the image and then say create a virtual machine out of it, right? So it is used to standardize the way your virtual machines are created in the VMware world or even in the Hyper-V world. All right. So here as well, yeah, the term image has not left us. We still have it. Now, what is there inside the image? How do you create an image? I'll open Notepad just to make notes. That's the Notepad. Okay. So the first step is to go ahead and create an image. What's there inside the image? The image will host our operating system and the application. I just said that when you are creating containers, you do not need the entire operating system. You need just what you need. It can pick up what exactly you need from that operating system, and that makes the operating system lightweight as well, right? Hey guys, if you have any question, please feel free to unmute and ask. So I'll quickly look at the chat.
Anand, since this is a webinar, the participants won't be able to unmute themselves unless we provide them separate permissions. So you can check the Q&A section and the chat box.
Lovely. Okay. Okay. So I will complete this demonstration and look at all of the questions in one go.
Yeah.
All right. Cool. All right. So here we go. Create an image. In order to create an image, you first need to know what the operating system is, and of course the application as well. You will have to install the dependencies, right? and I'll show that to you in a minute. But I don't want to bombard with a lot of commands at this time. Let's just uh, let's just start with something simple that we can pick up off the internet and start doing the proof of concept. Okay, so um, what I'm going to do is park this for a few minutes, just for a few minutes, and then navigate to, let's say, hub.docker.com, right? So I will quickly launch the browser here, and then say hub.docker.com, hub.docker.com. All right, so it's going to show up anytime, and I will sign in. Okay, I will sign in, and I will log in. I already have created my account here, and it's very easy. You can also create one. You don't have to put in a credit card, no debit card, nothing is required. You can just put it there. Uh, Account gets created in less than a minute, right? Type, 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 next, finish. No complex things. So now if I click on repositories, sorry, explore, you see that there are a lot of images here, a lot of images that are hosted by good companies like this Oracle, hosted by Java division, MySQL. This is an image that has MySQL database. This has an image that has Couchbase NoSQL database. And similarly, there are hundreds and thousands of images that are published by people like you, me, and organizations. So anybody can publish images here, right? So if you look at my repositories, I published an image called as Ding, whatever it meant at that time, and 13 times it has been downloaded, right? So, and if you look at explore here, you can also filter them based on the kind of image you want. So let's say operating systems, there's an image called as Ubuntu that you can download, image called as Alpine that you can download, CentOS, right? There are different images of different operating systems, and operating systems plus applications, right? um, so if I do not filter it, what do we see, right? So this has, if you just have to click on it to know what it has. So it will have it doesn't say anything because it is made by Oracle. They chose not to disclose any information right on the first screen. I have to check out and get that. But let me look at something non-proprietary. So let's say MySQL. What is that? Okay, reviews resources. Again, need to look at the documentation. But what I'm saying is that this particular image, MySQL Server Edition, will have the basics of no basic Linux operating system plus components of MySQL as well. What I'm going to do this proof of concept is look at a very simple image called as whale say, which is usually used by trainers to do the demonstration. It's called as whale say. Whale say. Let's see what I get. Docker space will say. All right. So here is a simple image called docker/whale say. It is only a tutorial, okay? And it's good to play around these things just to get a hang of it. It's just a taster. What happens if you say docker run, docker whale say, cow say, boo? What it's gonna say? You're gonna get an image like this with the whale saying something. So if you type, hey, how's it going? It's gonna type, hey, how's it going? Consider this Docker whale say as a hello world of your Python or hello world of your .NET, C#, whatever. This is where the world of imaging in Docker will start. Good to start or good to know the hello world things, right? So what I'm going to do is quickly pull this image first, right? Docker pull. So now you know a command called as Docker pull. Where am I pulling it from? I'm pulling it from Docker pull. I'm pulling it from where? From Docker hub. Now the question, a lot of people may have questions. Can I pull it only from Docker hub? Should I use Docker hub only as a repository? Can I host my images only in Docker hub? Can I not host it in, let's say, Azure repositories? Can I not host it in AWS repositories? How about Google repos? Can I not host it there? Can I have my private repositories, right? Maybe you have a repo on your premises, right? So Yes, the answer is yes, definitely. You can host it wherever you want. You need not pull it from hub.docker.com only. You do not have to host it on hub.docker.com only. You can host it anywhere, right? It could be on your private repos, it could be on AWS, Google, whatever your favorite cloud provider is, right? Okay, so at this point, we'll say that we're going to pull it from Docker Hub. So it says Docker pull. What is the name of the image? Docker slash whale say. So by default, Docker pull as a command will look at hub.docker.com only. I'm going to copy this image, go to my CLI, and then paste it. Okay. Oh, the paste thing doesn't work. Right click paste. So copy, 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 paste. Okay, it said Docker. Now, as soon as I hit enter, I did not hit enter yet. It's not executed. As soon as I hit enter, what will happen? It will go ahead and check whether that image exists on my machine. Probably I might have done something in the past, right? Maybe I was doing some exercises, labs, whatever. If it is already there on my machine, then it will not download it again unless there is an upgraded version available on hub.docker.com, right? I will do a control C. I did control C, okay, I did not execute it. And then I'll say Docker space images, hit enter, and this will show me all the images that I have on my machine. You learned another command just now. Okay, so it's called Docker space images. What is Docker images? To list all images on wherever you're running it on your device, let's say. All right, now I will say Docker pull. I will say Docker pull, Docker whale say, go to the internet, pick up that from the internet and throw it on my machine. So it's now checking if that exists on my machine. Okay. All right. Now let's read this line by line. Latest uses outdated schema. Please upgrade schema to for better future compatibility. Whenever it said something, and finally it is downloading 3.73 out of 65 MB. It's going to do that. All right. Give it a second. And now if I do it one more time, right, it's not going to do this. If I run it Docker pull, Docker whales one more time, it will not execute it again. Because it says you already have a copy, boss. Why do you want, right? There's no point eating up the traffic on the internet. All right, again, I may be taking longer time because I have a lower bandwidth. But in your case, you may have a excellent internet and it will not take the same time as it's taking for me. Yeah. Okay, now it is extracting. Extracting depends on your local computing power. It is not the internet now, right? So while it's doing that, I'm going to address a question from Sheikh Sultan. He asked, what is a snapshot, right? What is a snapshot? Um, Snapshot is called as point in time restore, Sultan. So let's say you got a virtual machine and you're working on that virtual machine doing something, right? You're doing something on it and you accidentally deleted a file and there's no way you can get it. Now what you can do is you can go for a previous snapshot. If you have taken a snapshot, it's important to take a snapshot beforehand. If you're doing a critical operation, you always take a snapshot, and something wrong happens, you can just fearlessly take the snapshot and restore from that snapshot. So you can do a point in time restore. You can go back in time, right? So let's say you took a snapshot 5 days ago and you want to restore it to that point. You can do that with the help of snapshots. Images are used for rebuilding something. If you want to recreate a virtual machine of the same kind, with the same software configuration, you can do that with images, right? I hope it's clear. And if it's clear, if you still have question, please put it in the chat. If it's clear, you can just say it's clear. Okay, looks like the extraction is completed. And now if I do Docker images, what am I going to get, guys? What am I going to get now? I should see one image. How many images should I see? 1, 2, 3, 20? How many? Okay, one. Yeah, lovely. Thank you. So let's see. Okay, I got one image. It's on my local PC, guys. It's no longer, well, it's there on hub.docker.com, but Docker images is not pulling internet, not pulling hub.docker.com. It is pulling your local PC. So I've got Docker Railsay. That's my local image. So let's go ahead and run this one. Docker run something. So now you're running another command. Okay. Oh, copy paste. Here we go. Okay, so Docker run Docker Rails. You now learned another command. It's called as Docker run. Oh, there's a typo. Docker run. Okay, Docker run. Docker run is there to call an image. You can also say execute. Execute. All right. Now I'll say cow says something like what? Where's my double quotes here? Okay. Cow say, hey, this is a great day. Who doesn't like Saturdays? Yeah, it's a great day. Weekends are great days. Hit enter, and I'm expecting the whale coming out of the water on my command prompt and saying, it's a great day, unless the whale is unhappy. There you go. So it says just what we executed. What happened here behind the scenes? Image was there, and we said Docker run from the following image. Let that get executed, and say hello world as an example, right? So what happened here? A container was created in the backend. A container was created in the backend with the information inside Docker slash whalesay. The program that is there inside the Docker whalesay was called, and a container was created. So if you run this command called as Docker PS, you will be able to see all the running containers. Okay, you learned another command, Docker PS. I'm making a note of all of them. Docker PS, not OS, PS, Docker PS, and it shows lists all the running containers, right? That's Docker PS. Now, if I hit enter here, there is no container. There is no container, but I just said that Docker PS will show running containers. Does that mean the container was created, whale said something, and the container got terminated? Exactly. Yes, that's what happened. So container was created and then got terminated. So if I run the same command following with the trailing hyphen a, hit enter, it shows me all the containers that were created and got terminated. Their job is done. And that's why they say that containers are ephemeral. They are short-lived, right? They are very short-lived. They will run only for certain duration of time. Well, there are syntaxes that will make it persistent, but by default, containers are ephemeral. They are short-lived. They'll do their job and get out. That doesn't happen to virtual machines, isn't it? Virtual machines are there regardless whether you are using or not. Containers will execute, and at the execution time, at the runtime, they'll take certain CPU and memory. Job is done. They terminate, they kill themselves, and give the CPU and memory back to the operating system, right? That's how it goes. So here, our container got terminated. Now, what are all these? There's a container ID, there's an image, there is what is that? The command that was run. It was created a few minutes ago, and the status is not running. It is exited. And the ports and all, right now this one does not have ports, but you'll see the ports as well in a minute when we run the next application, hosting the web application, right? And there's a funny name that's given to it automatically. It's called as loving underscore Driscoll or whatever. Okay, so that's a name. So what I can do is to remove this from my library. I can say Docker rm for removing, like the regular Linux command, and I can type the container ID. So I can say F428. If you are patient enough, you can type the whole thing, but the first two characters are enough for it to remove it. That's gone. Now if I do Docker PS -a again, it's not there. Docker PS, it's not there. Docker images, it's there. And what I can do to remove the image is Docker RMI, and then type the image ID 6B 3 6, and if you got the whole world and whole time, then you can type the whole thing, whole image ID, but it is still happy with the first 2 characters, and that's gone. So now if I do docker images, it's not there. So the command, again, let's update our sheet. The docker, what was the command? Rm is to remove the images. Docker rmi to remove the images. Okay, this one is remove the containers. All right, so in a short time you learned about 6 commands, right? And the docker version as well, we forgot that. I'm going to just put here docker hyphen version, or just type docker hyphen v, anything is okay. Lovely. Okay, so we got a few commands running. Let's go ahead and deploy that web application that I just showed you, right? This one here. And for that, we need to have on our own image. What we did earlier was that we got an image from hub.docker.com. But right now, instead of getting it from hub.docker.com, is my sound okay? There's one person, Sesetu, said sound is not all right.
We can hear you, Anand. Is anyone else facing the same issue? Okay.
No.
Okay, thank you.
Try joining from YouTube. We are live there.
Okay.
There. Yeah.
Okay. Okay, great. Let's go ahead. Thank you. So yeah, I was saying that we gotta go ahead and create our own image. We use this image here called as docker/whalesay, and now what I want to do is to create our own image. Right? How do we do that? How do we create our own image? The command will be docker build. So let's update this sheet here. Okay, docker build. Docker build to simple build an image. No company or no organization wants to make things difficult for the user, so that's why you got simple syntaxes. Docker followed by a syntax that you can remember all the time. There is no way you can forget these things because it's simple English. It's a docker build to build an image, rmi to remove an image, rm to remove the container, docker ps is a regular Linux command to list down the processes, so list all running containers. So if you do it a couple of times, the commands will be imprinted on your fingerprint, so there will be no way you forget it. Okay, so let's go ahead and build that image. Now, in order to build that image, you need to do this docker build from the following file called as docker file. Now, in that file, you have to specify different things like what is the operating system, what are the dependencies, what do you need, right? That's what you need to tell inside what? The docker file. Now I will open a docker file.txt which is already created. Blah blah blah. Okay, it says that when you, I'll open another notepad. Okay, right here. So what does it say? It says that when you want to build a docker file, right? When you want to build a image, sorry, when you want to build an image, the image should be of Nginx operating system, specifically the Alpine version. What is that? Where will it pick up from? Would it go to the internet somewhere and search all the internet to get that Nginx and Alpine version? That's one question. Let's address that. I will go to hub.docker.com again and type Nginx. Yeah, Nginx. And then, okay, Nginx. And are there any versions here? Oh, there are a lot of tags. There are all different versions. There's a latest version, also called as mainline, also called as 1.21. There's a Perl version. Oh, there's an Alpine version. Okay, so it looks like this particular command here, if I do docker build -f with this docker file, it will go to hub.docker.com and pick up the Nginx image, specifically the Alpine version. Is this the Alpine version? Yes. And what is there inside the Alpine version? all of this, right? It's all written in a particular language, um, right? So there are a lot of syntaxes that it is running, so it's going to pull all of that. You can go ahead and modify this. You can go ahead and modify this, put it in your own GitHub repository, fork it from here, right? You can fork it from here, put it in your own GitHub, and then customize it, modify it as per your requirements, and then call it as an image, right? At this point, what I'm going to do is leave it as default, of course. All right. So I'm saying that go to hub.docker.com and pull up Nginx image, specifically the Alpine version. Once you are done pulling that image, hey, can you go ahead and inject something into this folder? Inject what? So let's say I'm a developer and I developed this web application, right? What would the developer do? First, develop the application using Visual Studio Code or Python or whatever magic he has done, right? And he's written the code. It's there on his local PC. And I would like to copy all of this content, rather say inject that content inside this image that we just downloaded. So I'm saying copy everything here, copy everything into the following directory in this. So in your Nginx, you got /usr /share/nginx. Inside that, copy to that folder. Why to that folder only? Why do we need to copy to that folder only? Because that's the default web path, like in Windows IIS. So if you worked on IIS, where do you host web applications? In your inetpub folder, remember? See inetpub www root. In Linux it is exactly, thank you Binu, //inetpub www root. That's where your web application is hosted. In your Linux it is /var/www/html. That's where it is hosted. In Nginx, it is /usr share nginx html, right? That's the path where when you do http:// public IP, that's the path where it will go by default. Of course, there are ways to change it, right? So there is a Docker file that is created. I'm going to call this Docker file using the docker build command that I just mentioned here, right? Docker build, blah, 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 -f and Docker file. Okay, so let's do that. Um, but I need to first navigate to my path. Okay, I need to run it from here because my Docker file is located here. All right, so cd/, okay, lovely. And then go to here. Thank you. Okay. Okay, K Docker Lab, very good. CLS, I'm here. And then I need to run the command called as docker build with the following command called as -f. What is my file name? I'm doing a tab completion, dockerfile.txt. Well, in Linux, you need not type .txt there, but because this file has a .txt in the end, I have to type that. Okay, and then when the image is created, what do you want to call this image as? I want to call this image as, let's say, my app. All right, hit enter. There is an error. Docker build requires, I'm missing one argument. What could it be? Okay, okay, got it. Starting again, Docker build with the following file, and I want to name this file as my app. Okay, and then you need to put a dot here. A dot means that my file is right there. The dockerfile.txt is in that path, is what I'm telling. Hit enter. And -t also means tag. You're tagging that image. Okay, so it's building that from dockerfile.txt, doing its magic. Okay. And it takes some time depending on your internet speed, depending on what you're downloading, the size of the image and all. It takes some time. Okay, now the second phase started. If you look at it closely here, copy started. That means image is already downloaded on my machine. Now it is injecting all of this content inside that image. Is it completed? Like, you can just say Docker images. Oh, there you go. It's there. My app right there. Okay, so let's spin up a container. Let's spin up a container, and how do you run a container? I gave you a hint. Run, Docker run, right? And we executed that command earlier, right here, using Docker run. So I'm going to use the same command called as Docker run. And this time, since it's a web application, I need to host it on a particular port, right? So web application could be port 80, port 8080. I don't know. Depends on your environment. I don't know what port you want to run on, but I'll run it on port number 80, the default port. There's nothing running on my laptop. So Docker run, and then say what? Okay, -d, run it as a daemon, -p, the port number. I need to give internal and external ports. So it will be 80 internal, 80 external as well. And run it from my image called as my app. Enter. Ports are not available. An attempt was made. It says port number 80 is not available on my machine. It's crazy. So I'll change it to 8080. Okay, now it's good. It is happy with port number 80. Maybe there's something else running on my machine with port number 80. Okay, it's a crazy thing. Lots of things happen on my device. Okay. So this web application is pulled up from my image. Okay. And this image was created using Docker file. And finally, I created a container. If you see Docker PS, I should see that there's a container here. All right. Now let's go ahead and run http://localhost:8080 on my machine, and I should be able to see my web application, isn't it? Let's do that. So launch the browser. I will use Internet Explorer just for fun. Yep. Or I already have this Chrome browser. That's also fine. So I'll just say localhost 8080. Oh, where is colon on my machine? Here. Okay. Let's see. I did not get any response. Is there a typo? No. It still says port number 80 though. What is my browser? I'll change it to 80. Let's see. Yeah, it really doesn't want to work on 80 as well. Okay, port 80 is TCP, and I would like to troubleshoot this, but quickly. So I'll say Docker RM and 17. Docker, I'll remove this container, and you cannot remove because it's already running. So I'll have to first stop it. Docker stop 17. 1 minute, please. Please bear with me. RM17, removed it. Okay, so I should not have any containers. Okay, so now I'll run with, let's say I'll try with port number 80 again. Okay, but if I do Docker PS, now it's not running. Okay. Let's do this now again. There you go. So now it is running on port number 8080. So there was a small play that we have to run around these ports thing. It said that if you go on port number 8080, it will be redirected to port number 80, and now it is working. Okay, cool. So I've got my web application hosted. So earlier I was accessing with k:/ whatever my web app is. I double clicked on index.html. It was running locally via the drive, right? Like using the NTFS. But now we are able to access it with the HTTP protocol. All right. So that's running on port number. All right. Now what we can also do is run the same thing on the internet. Now you will not be able to access it, of course, right? Because your local host is different from my local host. You will not be able to access it. So I'm going to do the same thing on Azure. So I will go to portal.azure.com. I think I was already there. I've got too many tabs open. Okay, no problem. So I will quickly go to portal.azure.com. I'll do the authentication. 1 minute. Okay, so I'm logged into the Azure portal. What I've done is created a virtual machine here, and the virtual machine is Linux VM. That's the name of the VM. And this is a simple VM. There's nothing installed on it. It's just a plain operating system. What's the operating system? CentOS, that's it. And I've already connected to this VM. Okay. I hope it's clear what I'm doing here, right? Any questions? Let me quickly check the Q&A panel. Docker run image name. Okay. Sounds good. I'm just trying to see the Q&A. Okay. Oh, wow. There are a lot of questions here. All right. All right. Yeah, you're trying to help me out with 8080 thing. Thank you so much. Yeah. Yeah. Okay. Nginx images. So the question about why earlier we can't access with 8080, that's some problem with my device. Okay. The ports are kind of busy, so you don't have to worry about that. There are lots of applications running here. Could be something with my device. Uh, Created an EC2 instance and connected via SSH. No, I created a instance in Azure, not in AWS, right? Aditya, I've created a Linux virtual machine in Azure. What is the use of Docker Compose file? Anonymous attendee will take care of that later. Docker Compose is kind of an advanced thing. We are approaching towards Kubernetes. That's the direction we are going. That will be a different topic. And a lot of people tried to help me out when there were issues. Thanks a lot for being attentive and looking at the issue. That's the spirit of IT geeks. Susanto, what is a command or how to list the file inside the created images? List the file. So you want to go inside the image, inside the container, or inside the image? Um, is it possible to modify the attribute file inside the Docker or in chmod? Yeah, you can do that as well. You can do chmod, chown for those files. Yeah.
Sir, actually, I've answered some questions. You can go through that as well if you want to give more explanation to that.
Huh. Okay. There are a lot of them. I think I'll take hours explaining that. So I'll I'll definitely go through them. I'll pause the Q&A thing for a minute and then just focus on what I was doing. Uh, Interesting questions though. Thank you. Okay, minimizing that. So just to summarize what we did so far, we were looking at Docker. Installation on Windows was skipped because it's too tiny for you guys. You guys are experienced just about installing any file. Next, finish. Then we looked at different commands on Docker, like docker hyphen version, docker ps, and I was making a note of it here. I will copy and paste that once we're done with all of them, right? We pulled an image called docker whale say. We did docker images to see how many images we have, and we got familiarized with different commands. We also created a custom image, right? We created a custom image and use that to host a web application locally. Now what I want to do is do the same thing on a Linux machine, install it and show it over there so that it can be hosted publicly. So this will be infrastructure as a service, guys, right? Creating a VM in Azure or AWS or GCP is infrastructure as a service. So I'll keep the chat open just in case. Uh, Diogo Fernandez. Yeah, yes, we'll be demonstrating Kubernetes on Azure. I will do that. Um, so what I've done is created a VM and connected here already. It's a plain VM. There's nothing on it. Trust me. Okay. I will install Docker on it quickly. So I'll go to the Google and take help of it, say Docker for Linux. And I don't want to install an Ubuntu because it's not Ubuntu, it is CentOS. So it's a very simple document. Yeah. You just have to follow along, copy these commands. So this one is removing any older versions of Docker, and most of these don't have it, but I'll still copy and paste that. The next command will install the dependencies like the yum utilities. So I will do just that. Okay. And while it is doing that, I will copy the next command. This is adding the repository where Docker executables are available. Enter, repo is added. Next, I want to skip this. It is optional. I don't want to do any test repositories. There is no need for that. And finally, install the Docker engine. This is the most time consuming thing. Hit enter. Well, that's how simple it is. Even if you don't know Linux, you must know how to copy and paste. And I've been very good at copy and paste right from school. I know whom to copy. Right? The important thing is where you copy and where you paste it, right? That's the important thing. So that was just a joke, but this is gonna take some time. Depends. Now this is not using my internet. Of course, this VM is created on Azure, so it's gonna take Microsoft's bandwidth and do whatever it wants to do, and it's pretty quick as I see. So going to the dashboard on Q&A, open questions. Thank you. What is the use of Docker Compose file? Okay, I answered that. Can we install Nginx first? Yeah, you can do an Nginx installation first. Yeah, you can do that. Okay, yeah, we are exposing that on port number 80. Correct. Okay, so very interesting question by Rian Indrawan. When condition when condition we use containerization, is there any requirement or standardization? So probably you want to ask, when do you want to use containerization? Should we get carried away with these buzzwords? Basically, is what you're saying. Should we just go ahead and containerize everything under the world? So if you got an on-premise data center with tons and tons of applications, should you just go ahead and containerize them? Should you just go ahead and Kubernetize them? Not necessarily. There must be a use case for everything. Um, you need to know whether that application fits into the containerized world. Is there a need for microservices? Can that application containerize itself, right? Um, and there are lots of regulations as well that say, hey, this must be on a virtual machine. There are um, application based demands that say that this cannot be containerized. It needs an entire operating system. It must be there. For example, there was somebody asking, can you containerize Active Directory? Can you containerize DHCP? Can you do that? Well, you can do that. Go ahead. Can you containerize Microsoft Word? Can you containerize? Can you put Microsoft Excel on Kubernetes? Go ahead, do that. But what is the use case? Why do you want to do that? It needs to be running on the local server. You know, are you thinking about auto scaling that server? When you're using Microsoft Word or Excel or Active Directory, do you need auto scaling all the time? Do you need more and more resources all the time? Yeah. So there's some input from Fifi Paidu. It says you use containerization when you want to move from monolithic architect. That's the perfect term. Yeah, monolithic architecture to microservices architecture. Usually businesses and technical cases will help you make this decision. Perfect. Yeah. Monolithic, because it's a new terminology used here. I didn't want to use those heavyweight words, but then since it's here, monolithic just means that a single server, like the Lego that I was talking about, right? This Lego thing, a single server that has all the application stacks and everything inside it. That's a single server, right? You cannot move those different components. And if I just to talk about microservices for a minute, think about any web application that you've used in your life. Amazon, you've used Flipkart. Uh, People in the Southeast Asia region maybe used Alibaba, let's say Wish.com. So many of these. Now, if you look at that website, then that has several components. There is a shopping cart, there is a pictures gallery, there's a video gallery, there is an order book, right? There is a wish list section. All of these are different components. All these different components are sitting on the same server. They're written with the same language. Um, and that was a traditional way of doing it. Now what we are saying is that all of these components can be written in different languages, can be hosted on different platforms as well, and they all can communicate with the help of APIs. That's the concept of microservices. What I said in the beginning was monolithic architecture, and containers and Kubernetes enable, right, empower you to create such kind of microservice architectures, help you to move away from monolithic architecture. So if there is an application in your organization that you find as monolithic in nature, that you find can be split up into different kind of microservices, can be written in different languages and can be managed separately, then you would containerize them, or then you would love to Kubernetesize them, right? So that's the answer. But not everything can be or is recommended to go in a Kubernetes or containerized world. I hope I hope that I was able to address your question about should everything be containerized. Okay, so going back, looks like on the Linux VM, Docker is installed. So I'm going to go back to my practice of typing Docker version. What version of Docker is installed here? I just installed it, so should be the latest version. Did I? Okay, there's a typo. I should say Docker hyphen hyphen version. It says 20.10.7, the same one as in my laptop, right? Docker hyphen oh fat fingers hyphen v boy. Okay, that's 20.10.7. The same version on my machine is on the Linux VM as well. So what I have to do is get that web application on this Linux VM as well. So I'm going to type winscp and copy the content from my machine to the Linux VM. Okay, let's see how it goes. So I'm gonna copy the public IP. There you go. My WinSCP is open. Um, where are you? Okay, here. Copy that and paste it. And I will type my credentials for a second. Please close your eyes. No, I was just joking. So root admin. Oh, let's see how it works. I think I typed the credentials incorrectly. I typed it wrong. Yeah, perfect. Yeah, I did. Let's see now. By the way, in Azure, you create a VM, you can forget the password and still reset it later. Okay. Okay. Finally, I got connected, and that's the yeah. So on the right hand side is my Linux machine, right? Yeah, this is my Linux machine. This one on the right box is my Linux. On the left side is my Windows machine. So I need to navigate to the K drive, and that's where my web content is right here. So I'm gonna just drag and drop. That's it. Tools must be easy. They must not be complex. And WinSCP is another simple tool. Mm, yeah, take your own sweet time. I've got a slow internet, so that's how it is. All right, so just for fun, what I can do is, let's see, I'll just do ls here. Okay, I've got some of my files being copied, right? Oh, yeah, good. Okay, they're being copied. Yeah, we gotta be patient, just a few more seconds, and it should be there. Time elapsed and time left. Oh, 1 minute is a lot for me. Okay, so in the meantime, let's go ahead and construct the command for Docker build, right? We need to make an image. So I'll clear the screen and say Docker build with the Docker build file. And the Docker file name is docker file.txt. I'm laughing because using .txt on Linux platform, it's only because the file name is .txt. It's gonna get copied as it is, isn't it? Where is it? Yeah, it's gonna get copied as it is. Either I rename it on Linux machine and then run it, but it really doesn't matter. And say hyphen tag and call it as what? Call it as I'm gonna call it as Whizlabs, right? Whizlabs. Let's say hyphen t Whizlabs, and then I'm gonna put a dot and hit enter once the copy thing is completed, right? I hope you're following me here. Yeah, it's all copied, happy, and hit enter. Cannot connect to the Docker daemon. Why? Is the Docker daemon running? We installed the Docker Docker tool, but we did not start the service. That's so dummy thing. And there's a command here to start the service. So we need to start the service, guys. Okay, Docker start. And now I'll run Docker build. But permission denied. Yeah, I need to run sudo. Thank you. So it's gonna pull that up from the internet, do its own thing. So basically what we're doing is doing the exact same thing what we did on our machine, right? On a Linux machine in Azure so that we can publicly access the web page. So it was quick. It downloaded as well as injected the code into the image. Now if I do Docker images, I should have the image. Oh man, I must always do sudo, or I'll just do sudo -s so that I don't have to do it again and again. All right, lovely. I'm going to do it as root this time. I've got the keys to the kingdom. So if I do Docker ps, no container, a time to run a container on my Linux machine. So I got to do Docker run now, right? Docker run. Remember what we did. -d for daemon, -p for the port number that you want to run, 80:80. Where's my colon? 80:80. Am I missing something? Yeah, I need to tell the image name. What is my image name? I said Whizlabs, right? Whizlabs. Whizlabs. Am I missing something here? I don't think so. So I'll hit enter, and there you go. So I'll do copy this URL and paste it here. I should be able to access it. There you go. We can also access it. Just pick up this public IP. Can I put it in the chat? Where's the Zoom here? I don't know. Okay. Chat. Where's the chat? Anyways, I'm not able to. So there's a chat here. I click on it, but it does not pop up. More chat. It shows me Q&A. Here you go. So I'll just copy and paste it here. You should be able to access to all panelists and attendees. Copy paste. Okay. So you got the public IP in the chat, and now the website is hosted publicly. It's quick. So this web app is running inside a container on that virtual machine in Azure. Are you able to access it? If yes, you can just say yes. If not, then we'll troubleshoot. Lovely. Okay, cool. So this is a public website, right? We are able to do it so quickly. It's just the developer who has to give the code now. Most of the time is spent by the developer to make the code. And how much time do we take to host it? Seconds, right? Quick. That was fast. So that's that. That ends the discussion for containers 101. Just the beginning. It's just the beginning. Okay. So if I was just thinking of this example. Let's say you want to drive to a beach. You're driving to the beach and you're like, 300 kilometers away from the beach, and you start driving towards it, and you're very excited. Your windows are half down. Your windows are half down, and you're driving and driving, and now you're like 200 kilometers away. You're still excited. Now you're like 100 kilometers away, and now you can actually feel the fresh air. You can feel the smell, the wet smell of the beach, right? But you don't see the beach anywhere. It's nowhere close, right? So you just get the feeling of it, but you're nowhere close to it. That's exactly what we did today. You got a feel of it. You got a touch of it. It's just to give you a taster, okay? It's not the entire menu, right? You're not at the beach yet. There is a whole vertical curve to learn containers, Docker, Kubernetes. There's a lot of things inside it. But again, this is only to give you a taster. Don't get scared. It's all logical. It's all logical. Nothing is complex. People will not make complex applications for us to handle, right? And if they are making complex applications, then that's not the right company to work with. you know, Docker, Kubernetes, Google, it's all pretty much logical. And I'm sure if you're in IT, you got the logical head, you got the logical thinking, and you will be there pretty soon. So nothing to get disappointed. It's easy only if you put efforts. So here we are with the containers. Let's go ahead and jump into Kubernetes slowly. All right. Um, that being said, I will quickly take a peek into the tutorial. What was our activity? Create a web application, create an image, and the image will host the OS. That's what we did, and push the image to Azure Container Registry. That's an awesome thing. So far, there's no fun. There's no fun here because we hosted a web application on infrastructure as a service, and a lot of companies and people who have worked in the cloud, a lot of companies want to stay away from infrastructure as a service. The cloud adoption program has been mostly around platform as a service and software as a service, guys. So let's go ahead and quickly push this image from this local machine to platform as a service. Okay, so I will go to where? Azure. uh, I don't need this anymore, so I'll close it. What else do we have? Unnecessary things. I'll close this as well. I'll close this as well. Okay, I'm here. Now, the question about whether you can host an image in Docker Hub only will be addressed now with a proof of concept, with a proof as well, that Azure also has a repository where you can host the images. Let's just do that. So I will go to the search box here and type containers. Okay, in container instances, I can create a container, but what I want to do is create a container registry so that I can keep my images there. So I'll click on create container registry and then create a container registry. So what I'm doing here is creating a placeholder, a repository of images. So this is like a folder in which I can keep jumping in all the images. Okay, so I will select my resource group, and then registry name is, I'll just call it something, right? Alpha, hosted in East US. Okay, alpha is already in use. 1.2, is that happy? Alpha 12.azurecr.io. Okay, I'll leave the SKU as standard, hit next. Networking, yeah, I want to access it via public. It's grayed out because I did not choose premium. So you pay money, you get private endpoints as well. You want to keep it free, then leave it standard. And now it is public, hit next. Do you want to encrypt it? Again, this is disabled because it's not a premium version. Hit tags, review, and create. So even if you don't know Azure, don't worry about it. Just like next, 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 and finish. Like I said, technology is easy. It's just that you got to spend time and understand what's the functioning of that radio button and this checkbox and that drop down menu. All right, so my container registry is created. I want to push this image. So if I look at Docker images, do I have an image here? Yeah, I want to push this Whizlabs image to my container registry so that other developers can use it. Okay, because so that others can download it, make modifications, give recommendations. So it's going to be a central repo. So how do we do that? Well, I need to first authenticate myself. right? I need to first authenticate myself. So the way I will do that is by going to the where's my VM? Right here. Okay. Okay, I'll clear the screen, and I will also close or minimize this command prompt here, and I will say docker login. Okay, as always, do mistakes. Docker login, there's a typo. And log into what? I will uh, log into this guy who is alpha12.azure.cr.io. I'll copy that, but I also want to tell you that you need to enable the access keys. You need to enable this, and that's when you will be able to authenticate. You'll get the user ID and password. So, all right, I'm getting mixed up here. Okay, Docker login to that, and then it will ask me the username, which I will copy from here, paste it, and password, copy, and paste. Hit enter. Your password will be stored, blah, 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 blah. Looks like login is succeeded. Now it's time to push. We use the command called docker pull. Remember, now is the time, now is the time to push the image. Which image? Docker image. You need to push this image to the repo, right? Docker images, sorry. You need to push the Whizlabs image to alpha12.azure repo cr.io. Okay, but before you do that, you need to tag it appropriately. Okay, because that's a prerequisite. You need to tag it appropriately. So I'll say docker tag. Hey, another command. Okay, I'm missing something here. So you looked at docker login command, logging into a particular repository, then docker push command, and docker tag. Okay, I want to retag what? Whizlabs as as alpha 12 dot what's the name of it, sorry, azure.cr.io. Okay, azure.cr.io, and then I will say Whizlabs new, hit enter. Now if I do docker images, typing docker images, okay, I've got a new one here. I can push this, I cannot push this, so that's the prerequisite, that it must be named like that. Now you can type docker, yeah, make mistakes, docker docker push what, this one. Okay, oh man, docker docker push. I'm already authenticated, so it's gonna push it right to Azure. So now if I look at what the repositories, I should have my repo called Whizlabs new. All right, I can create containers now. So if I go to the search box and type containers, I want to create a container instance. You're following me, right, guys? Or am I just doing my lab? I hope you're all with me. With me? Yeah. Uh, lovely. Thank you. Thank you for your attention. Okay, it's a long lab, unfortunately. Usually the time span, I was just reading some studies, the time span is usually limited to 45 minutes to 30 minutes is what people say, but we are from IT. We got a longer span. So prod, so I'm gonna put that in a resource group called rg from hyphen dev and give the container name, let's say Whizlabs app in East US, and now I can say that my application is inside Azure Container Registry, and it automatically picked up the registry image and the name, right? Now I can just hit next, next, next. I really don't care. Public DNS name. Yeah, we can give a DNS name to it. Let's just say Whizlabs app or something. I'll just finish through this and review and create. You know what? Your container is ready, and and you're now you have now hosted the web application in platform as a service. This VM is infrastructure as a service. So you created a container in infrastructure as a service earlier, and now you are creating it in platform as a service. Deployment failed. Yeah, happy. Errors must always be there, right? Whizlab apps is not accessible. whatever in container, please check the image and registry credentials. Yeah, I've seen these messages earlier. Uh, we just have to recreate it. That's it. That's it. Container instances, because the image was created just like few seconds ago, right? So it could not identify everything. You must give it some time. Container name, let's just type again, Whizlabs app, and it's inside Azure Container Registry. Hit next. I'll give it this name. Next, next. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Click create. I'm just counting. Okay. Let's see. Let's check our luck this time. Stay hydrated, guys. Keep drinking water. It's important. So now I think there's no error message so far. It's gonna pick up. It's gonna pull up. Ha! Errors again. What did it say? Alpha 1, 2 in a container group is not accessible. It's not able to communicate with that image. It's not able to communicate with that image. And with my experience previous in the prod environment as well, the developer pushed the image, but then when we are trying to create an image from using the container services, it says the image is not available, and we tried the next day. It worked. So what we did is, thereafter we checked in our dev subscription. We tried it after a couple of minutes. It worked again. So let's just give it some time for it to sink in. Okay, I'm not gonna say that let's leave it, but we'll never leave it, right? Because we got an error, we'll not sleep till the time we solve it. That's how we must be. But for now, let's just park it. I'm saying that let's give it some time. Otherwise, I would have Googled for it. What's the error message? How do we solve it? And probably taken a Panadol and some pills to get out of my headache. But for now, that's not a problem. Just give it some time for it to sink it, and we will resume back to this. We'll come back to this lab. For now, let's talk about this one, the lab. Push the image to container registry. You understood that? Pull the image to create a container. We tried to do this, but it failed because it's of its own habit of failing so quickly, but we'll try it again. We have suggestion from Sandeep. Says, I think we have the same names twice for the images. Okay, when we're doing the next time, we'll take a look at that. Yeah. So now a quick tour of Whizlabs. Oh, okay. Looks like I got a break, guys. Abhishek, stage is yours. Yeah, you're on
Hello
mute.
everyone.
Hey,
I
yeah,
hope I'm visible here.
yeah.
Yeah, just give me a minute. So I'm putting myself on a spotlight and I'll take over your presentation. Can you please stop sharing?
Hmm, definitely.
Sure. So let's begin with what Whizlabs has for learning the hands-on labs. So this talk is very short, explaining about how Whizlabs works and how what type of labs that we have currently. And we'll start with understanding the Whizlabs platform. This is the first agenda of today's. Second is exploring what type of Azure certifications are. So as you know, there are three types of certification. First is fundamental, second is role-based, and third is specialty certifications. And then we will see some lab features that we have. And at the end, I will take over your questions and queries that you have. Okay, so let's see what is build hands-on in live environment. So till now, what you have been doing is you have been watching something and you refer some guide and read about it. But what we're gonna do with Whizlabs is we will give you a free account for the particular duration of time where you will get to explore with the steps that is help to explore the real you. So for one lab, we have guide for each steps that you are present with. So it will start with brief description of lab, introduction to the services that were used in the labs, and probably an architecture diagram of the lab. For the task, we have all the individual steps in the details. It requires screenshots of AWS console in case of AWS labs, Azure console or Azure UIs in case of Azure labs, and GCP for the same thing. So we'll see all the required commands that are present. And also, whatever you do, you can just validate to verify whether you have done it in the correct way or not. And these are some, each resources will have an automated code present in the background that will run for you. And if the outcome of the lab is not expected, the resources will give you steps to fix it. And you can submit the feedback to let us know how was the lab completely all about. So here, you don't need to set up your own infrastructure in your account or need to worry about your credit card information. And learning here is completely risk free. So let's say if you are not able to do a particular task, you can just end the lab and do not have to worry about whether the resources that been created by me are deleted or not. And also it will give you a good hands-on lab experience. So let's see one of the lab that we have as a demo. It called as deploy container instances, Azure container instances on Azure environment. So I'll just switch back to the environment you have. So you can just here search for this course called Microsoft Azure Fundamental AZ900 certification. And for this, you will get online course, you will get practice test required to pass that exam, and also the lab activities. For Azure, we don't have much labs, but there are few, and we are trying to develop few more in the near future. One of the labs that I will just walk you through is how to deploy the Azure container instances. So you can click on the start button, and as soon as you click to start button, you will be redirected to play.whizlabs.com. This is a playground for labs, and here it will be given about all the lab activities, lab details that are present. In this lab, you will be displaying a static HTML page with the duration of 30 minutes. The task that you will be performing is completely given here with the introduction to what Azure container instances are. And to begin this is very simple. You can just click on the start lab button and follow the guide completely. And we'll be adding more labs and more feature to these things very, very soon. So if you are a Whizlabs customer, have purchased any particular course or purchased a premium subscription or annual subscription, you will have access to the courses. So I'll just show you how this courses looks like. You can log into whizlabs.com and switch over to My Courses. So once you click on the My Courses, present on the top side, you will be able to see all the courses that are part of your portfolio or part of your bucket. And I have clicked on the My Courses, and here I can see all the courses that are present for me will be listed. So if I have started any course, it will show the progress in progress, and there will be a quizzes, labs, videos, and also the validity of the same. Okay, so now let's explore the next steps, that is the Microsoft certifications that we have. Okay, so I'm now on documents.microsoft.com/learn/certification, and here we have certification for all the roles type that are present with like developer, administrator, solution architect, data engineer, and all of them. And also these certifications are based on fundamental, role-based, and additional. So you can just click on this, any of the lab button, and get the access to the certification. But in case you want to explore what are the courses that we have, you can reach out to this link, check out this link, and it will have all the courses of Azure. So to access that, you can click on the courses from the homepage and click on the courses that are present with under cloud computing, Microsoft Azure. So once you click there, you will be redirected to this page, and you can access all the courses. If you are a premium customer or if you have purchased an individual course, you can list them here and try it out. So this all the courses are high rated, and so if you have any queries with the lab, you can just post in the chat window. Thank you.
Lovely. That was quite informative. Yeah, we all need labs to play. And one way is to create your own account or use Labs. You need to have a credit card or something to create your own account for AWS, Azure, Google, whatever. But if that is concerning, we have a solution now. Awesome. So I'll flip back.
Anand, you are not audible. No, we can't hear you. No, still on mute. Mm, no, the audio is not audible. Can you try joining again, maybe?
I don't know.
Yes, working now. No, you again went on mute. Your sound came in between, but now it's the same again. I think it's something to do with your cable.
I'll disconnect and join again.
It just came. Speak again? No. Yeah, join again. Okay, everyone. While Anand is joining back, I'll quickly walk you through all with Whizlabs 100 Days of Cloud Challenge. I'm sure some of you are already a part of it, but if you are not, we launched this challenge on 12th of June, and it's day 22 today, and we are getting a humongous participation from lots of you, and it's going well. So if you still want to join it, you can join from today as well, and we have some really exciting prizes for all the participants who take part in this challenge. There are some exciting activities for you all to do, and yes, feel free to make the best use of this opportunity. Yeah, Anand. No.
Can't hear me, right?
Now I can. I just could hear you.
Now, better? Okay. Should we continue?
Yeah, we can.
Okay. I don't know what changed. There's nothing that I've changed, but
No problem. It's working.
yeah, technology wants to play monkey sometimes.
Please carry on. I think you went on mute again, Anand. Can you try using any other headphone or something? Or maybe try doing without it?
Yeah, I just removed the whole headset thing. It's coming from.
Yeah, it's working.
It's better
Yeah.
now.
Yeah, it's working now.
But I hope the quality is still okay.
Yeah, it's equal.
Absolutely.
It's the same. Yeah.
Lovely. Okay. Yeah. So that's the monkey business. Sometimes, sometimes, yeah. This is what's called as a monkey business. Jumping around the mics. Okay. So do we really need Kubernetes? Now we got a demonstration of
um, demonstration of containers, right? And there's a lot goes behind web applications, guys, and you guys have got lots of experience on your shoulders. You know what I'm saying when it says that there's a lot that goes behind a web application. The developer does their job, the application comes to us, the code comes to us, and we have to deploy it on maybe virtual machines, maybe behind a load balancer, take care of the networking, open the right set of ports, give the right set of permissions to people, role based access controls, permissioning, security of the web application. Where do you keep the keys? And this list, from technical things to non technical things, including compliance, governance, enterprise security, just goes endless sometimes. It goes from a project based to operations based as well. We need something that can orchestrate the behavior of web application. The web application is subject to a lot of load sometimes there is no load at all. Think about cyber monday sales, or big billion day sales, or amazon day sales. We all connect to the web application, let's say amazon.com, or your favorite e-dealer, right? E-website, e-commerce website. And just like you, there will be thousands and thousands of people connected at that time, because the sale is only for an hour, for a day. At that time, since there is a lot of load on the server, it really, when I say it's the hardware. The hardware really goes through a lot of CPU cycles, a lot of memory cycles. So it needs humongous amount of computing power to cater to the needs of the people who are accessing it. Users, you and me, should not be disappointed, right? We should get a good performance right from the time I select the product till the time it goes to the cart, and then I finish my order. There should not be an iota, a small percent of a hiccup in the performance. Because the moment I see performance problem, then I will probably stay away from that web application and give negative marking as well. Containers by itself are not that intelligent to do orchestration. When I say orchestration, it needs to do a lot of things. For example, automatically scale based on traffic. And when I say scale, it's just not scale out, but scale in as well. Horizontally scale, create more and more instances behind the scenes when it's required. And when the sale is over, let's say in the night at 10 o'clock, you don't see much traffic. So the instances or the containers must automatically be terminated. The amount of storage must must be increased and reduced based on the traffic, right? There must be some kind of a system that does just that for you. An orchestrator does that. Kubernetes is one such kind of an orchestrator. Just like Docker, Kubernetes is not the only one. There are lots of them in the market. But Kubernetes was one of the first ones. It was made by the Google, not the Google, it was made by Google and then donated to CNCF. CNCF stands for Cloud Native Cloud Foundation. You can search for CNCF on the internet and you will see all the products that are under the CNCF umbrella. There are different layers we are talking about when it comes to a web application. 3 tier is mostly reference. So you got the load balancer in the first tier, the application itself, and the database. You know what I'm talking about. You probably might have already picturized it in your head. The load balancer, the traffic hits the load balancer, redirects to the application. Application sends the CRUD operations to the database. CRUD, right? Create, read, update, delete operations to the database. That's a simple 3 tier application. Now let's assume that the application tier can automatically scale in and out based on the traffic, right? The Kubernetes should be able to handle all these 3 tiers in itself. Am I saying that Kubernetes can handle the load balancer? Am I saying that the Kubernetes can handle the applications and the database as well? Yes, I'm saying that. It can provide auto scaling, right? There are a lot of plugins that come around Kubernetes that will help you achieve a lot more, like monitoring as well. There are a lot of third-party tools. For example, let's say Prometheus is one of the upcoming ones that you can get along with Kubernetes to ensure that you got good monitoring in place. Yeah. So it can take care of your nodes, containers, cluster of containers, load balancers, monitoring. So for the infrastructure guys, Kubernetes would be a one-stop shop to do everything when it comes to hosting web applications. All right. So far today, we have hosted containers on the local machine by installing Docker. Then you installed containers on the virtual machine, which is infrastructure as a service. Then you installed containers on platform as a service as well in Azure. We'll then take a look at how can you host the same thing on Kubernetes. How can you do auto scaling, right? Before we do so, it's paramount that we understand the architecture of Kubernetes, right? It's very important to understand the architecture of Kubernetes. What are the various components of it? When data flows, when the developer puts something or runs a particular command on Kubernetes, then where does it run? Which component is responsible for auto scaling? That's what we'll understand with the Kubernetes architecture discussion. It's important. If you look at the picture here, the screen is shared. There are two blocks to it, one on the right hand side and the other one on the left hand side. On the right hand side is the worker node. There could be multiple worker nodes. Worker node is nothing but a machine. It could be a virtual machine, it could be a physical machine, it could be anything. And on the left hand side is a master node. The white box on the left hand side, the whole thing here is the master node. The right side is the worker node. Okay. So the first thing that's inside the master node, the most important component is the API server, right? The API server is responsible to take all those commands from a developer. Let's say he's running the kubectl command or the UI or via the UI. So any kind of executions that are happening on the Kubernetes cluster is happening via the API server, right? So the commands will then be submitted to etcd, control manager, or Docker, or kubelet proxy, wherever the command is going, but the command must first go through the API server. That means that the API server is the front end of the Kubernetes architecture. Anything that goes into Kubernetes design will go through the API server. API server determines whether those requests are valid or not, and then it will process them and it will send to other components using API calls. Then there is scheduler, right inside the master scheduler. It will tell you whether your cluster is healthy or not. Is your cluster healthy? Is there a need for new containers? So as you see here, this whole box here, you got containers inside it. There's a concept of pods as well. We'll talk about it in a minute. But for now, let's just think about this whole section as containers. Scheduler is checking if new containers are needed for the application. So if auto scaling needs to happen, it will check whether new containers are required and in which node will they fit in. There could be multiple nodes, like I said. In this picture, there's only one worker node, but there could be more worker nodes as well. So scheduler is checking whether new containers are required, and if required, in which node should they go and sit in. These are the concerns of a scheduler. The scheduler considers the resources that are required by the pod. What is a pod here? We'll talk about that, but since you're already referring to these terms time and again, this circular thing is a pod, right? This inside the Docker runtime engine, you are maintaining a lot of pods. These circular things are pods. Inside the pod, you got containers, right? So if you need to maintain a container, if you need to manage and provision a container, it must happen via the pod. So scheduler will check whether the container needs to be hosted on a particular worker node. And if on this worker node it needs to be hosted, then it will go on a particular pod, right? Is that pod healthy? Does it have enough CPU and memory? How's the health of the entire cluster? These are the concerns of a scheduler. The next one is the control manager here. Control manager is taking care of your entire cluster. It will consult the scheduler, yeah, and make sure that the correct number of pods are running. Scheduler is hosting the containers on the right pods, whereas controller is ensuring that there are right number of pods inside that worker node, right? And if that pod goes down because of some reason, if it goes corrupted or something, then the controller is the one that notices it and responds to it. It brings up new pods based on the application's lifecycle. etcd is a database. etcd is a single source of truth. If you ever want to query your number of pods or containers, it will contact etcd. So let's say you are running a command via kubectl and saying, hey, how many pods do I have? It will contact this database. So etcd has all the information about how many pods do you have, how many containers do you have, how many images are running, what is the state of kube proxy. It's all stored inside etcd. So etcd is a information, right? Information database. You can query, and when you query the cluster, etcd will give you that information, right? So you got a master node and you got a worker node. There could be more worker nodes as well. A Kubernetes cluster needs at least one compute node, but usually we'll have several. Pods are scheduled by the scheduler, and they are orchestrated to run on the nodes. If you need more and more pods, then you need to host more worker nodes. Pods, what is a pod? Pod is the simplest and the smallest unit in the Kubernetes object model, right? It's the simplest and the smallest. That's where the containers will go and sit in. Each pod will have sometimes a single container, sometimes multiple containers as well. It all depends. So if you want your application to be tightly coupled, that means they're all dependent on each other, then you will have multiple containers inside the same pod, right? The container runtime engine here is a Docker, is the Docker. In this case, it's the Docker, but it could be any container runtime engine. Docker is not the only one. There are a lot of supported container runtime engines called RKT like Rocket, CRI-O. Well, these are also supported and are well recognized in the cloud native cloud foundation domain, right? These are open initiatives, open, just like Kubernetes, these are also open. So Kubernetes design supports not just Docker, but also RKT and CRI-O. Kubelet, I told you about API server, that any kind of information that needs to get into the master node will go via the API server, and API server will then send API calls to other components inside the cluster. Just like that, there's a kubelet. Kubelet is again a CLI. Yeah, it's a simple program, and any command, any execution that needs to happen into the worker node will happen via the kubelet. Kubelet is a tiny application. Kubelet makes sure that containers are running in a pod, and if scheduler or control manager or API server is sending a command to worker node, it is sending via the kubelet. Kube proxy is responsible for networking and internetworking of these containers. So if a container needs to be exposed to the internet, you need to do http:// access the container, then it needs to go via kube proxy. You need to put couple of virtual machine, couple of containers behind the load balancer, then it needs to go via kube proxy. Intercommunication between containers is also done with kube proxy. So networking components like packet filtering, forwarding the traffic is all done by kube proxy. This is the architecture of Kubernetes, And these are all the various components of Kubernetes architecture. Okay, let's go ahead and do a demonstration of Kubernetes in the Azure portal. So if I go ahead and type, let's say, Kubernetes walkthrough in Azure, you'll bump into a document, and you can definitely go through complex implementations, but the audience is not right here for the complex implementations. I see some of us have already been through the Kubernetes world based on the initial introductions, but some of us are starting with 101. And for them, I would suggest that we start deploying a simple Kubernetes application in Azure, right? Uh, the application will be accessed via the public IP, and you will be able to access that application like this, right? Just like the way you write Docker file, when creating images for the containers, here you have to write everything in YAML. YAML stands for yet another markup language. So let me write down what I just said. YAML, not TAML, but YAML. Yeah. YAML stands for yet another markup language. You need to write everything using YAML. You need to tell that, hey, this is the image. Hey, this is the port. Hey, this is the load balancer I need to access. You need to tell everything inside the YAML file, and then finally call using kubectl command. A lot of things can be handled and managed by kubectl. Okay, kubectl command. So if your journey has already been into Kubernetes, or if you want to pursue your journey into Kubernetes, kubectl will be your best friend. Kubectl and its syntaxes inside kubectl must be on your fingertips. Or if you have already been there, you know what I'm talking about. So here it says that you go ahead and create a resource group. Well, let's directly get into the YAML file here, and let's understand this one. Okay, what does this YAML file say? YAML file says that the kind of deployment is deployment. I want to deploy something, right? And the name of my deployment is Azure Vote Back. And there is another deployment as well, which is called as Azure Vote Front. So there is a backend deployment and there is a front-end deployment. Okay, so the backend will be the database, the front end will be the web application itself. Why do you need a backend as a database? I need a backend as a database so that when I hit these buttons, cats, dogs, these numbers change, and these numbers must be stored somewhere, right? Cats, dogs. So that's why I need a database to store those numbers. A front end, of course, I need a front end so that I need something to press the buttons, right? That's a front end. So using this YAML file and deploying a front end and a back end. The front end is called as Azure-Voteback, and it is picked up from an image which is hosted on mcr.microsoft.com. And I'm picking up, sorry, it's a backend, not front end. The backend is a Redis image. What is a Redis? Redis is an in-memory cache, right? Redis is an in-memory cache. It's not like a database. It's not like NoSQL. It's not like Microsoft SQL. Anything that's stored on Microsoft SQL or NoSQL databases is stored on your hard disk. But when it comes to in-memory databases, they are stored in the RAM. It's in the memory, not on your hard disk, not on your persistent storage. So it is saying that I'm going to use an image, image Redis with the following version. And then it's allowing the following parameters. Empty passwords are allowed. And it is also giving you the maximum amount of CPU and memory it can consume, and the port number on which it can be exposed on. Then there is a service that it is being created, which is exposing it on 6379 port. Then there is a front end. The front end is also on image, which is based on Linux, and that's the front end image. and the CPU and memory is allocated here, deployed on port number 80. And finally, a load balancer is also being created, which will connect to that Azure Vote front on port number 80, right? So just by copying this and creating a file called as azurevote.yaml and running this command called as kubectl apply-f, it will go ahead and create a Kubernetes cluster with all of these parameters. So the first thing is to go ahead and write this YAML file, right? Okay, so what I'm going to do is create a Kubernetes cluster in Azure, because the documentation says so on the top. They are doing via CLI, but I'll just do via GUI. So I'll just say Kubernetes services and click on create a Kubernetes cluster. We're exceeding the time, guys, but I hope this is informative to you. There must be a lot of plans. It's Saturday. It's getting late as well. I really appreciate your patience. We're exceeding the time limit, but my only objective here is to give you knowledge as much as I know. I'm not saying that I know everything. The person who says that I know everything is a fake guy. I'll never say that, because I'm learning. Just like you, I'm learning. I'm into several areas. Constantly try to pick up something else. But here, what I'm saying is that it is extending the timelines of 2 hours. That was not planned, but I appreciate your patience at this time. Thank you, everybody, being patient and being supportive. So I will create a Kubernetes cluster and select the resource group, give it a Kubernetes cluster name, and I'll call the Kubernetes cluster as Happy Saturday. Saturday. Okay, and I'll leave these options default. And you see it's creating a Kubernetes cluster. But one important thing here is, before we go by the defaults, in node count, it is creating the worker nodes, guys. Number of worker nodes is 3. In the Kubernetes architecture diagram, we had only 1 to explain, to make it simple, but you can create multiple nodes as well, right? I'll leave these options default, authentication, networking, let it go via kubenet, that's okay. Yeah, so if you got a web application on a container registry, you can do that as well. Hit next, tags, and I'll say review and create. So it will take like few minutes. It's not quick, right? It's not instantaneous to create a Kubernetes cluster. It takes few minutes to do that. And click on create, okay. All right, so the deployment is in progress. Okay. All right, while the deployment is happening, if you're new to Azure, I want to tell you something, that there is a CLI option. So you do not have to run any CLI commands from your machine. So you can just click on it, and then it opens a new box that can handle your PowerShell scripts. I'll create in my prod subscription and click on create. So it can accept PowerShell commands as well as Bash commands, Linux commands, CLI commands. So pretty amazing service from Microsoft. It's also there in Google Cloud, by the way, in GCP as well. You can run a CLI based within the web interface. Yeah. So we got 2 things running. The Kubernetes cluster is being created and the Cloud Shell is being prepared for us. So now what do we do? Let's go back to the document, going to the beginning. It says that you will be able to create an application like that. What is a prerequisite? You need a Bash environment in Cloud Shell, which we just launched. You need to have, well, if I got Azure CLI, so I don't need to have Azure CLI installed. You need to create a resource group and then enable cluster monitoring, create a Kubernetes cluster, which we did using the GUI. And finally, you connect to the cluster using these commands. And this is where we'll start from once the Kubernetes cluster is created. All right, looks like this is ready. Okay, let me clear the screen. And while it's being deployed, what I'm going to do is bring that YAML file here. Okay. So I'll copy this YAML file and call it as, let's say, VI editor. I'll open a VI editor, guys. If you're familiar with Linux, you know what I'm talking about. But if your career has been around Windows, VI editor is just like a notepad editor. You open and write text inside it. So I'll just call it as VI apps something, hit enter, and it opens some file, and I can insert content inside it, uh, and it copies everything, and I can just say write and quit, right? So whatever is the content of this YAML file is now inside this apps. So if I do cat apps and hit enter, oh, okay, there's a typo. You see, everything is right inside that file. Okay, so ls, I've got a file called as apps right there. Now what I need to do is run that Kubernetes command, which is kubectl apply -f. But then before that, we need to connect to this cluster. Right, you need to connect to this cluster, which we did not, because the cluster is not created. Yeah, so we just have to wait for this. In the meantime, I'll go pick up some questions from you. So how can we check? There's a question from Aditya. How can we check the deployment status using kubectl command? Yeah, you can check that. There's a lot of syntaxes to verify. Um, yeah. Okay. Thank you, Aditya. Now the question is another question, interesting question from Shenif. Do you run your traditional databases, Oracle, SQL, DB2 on Kubernetes, or do you run different one? Very interesting question. I've seen environments running Postgres databases as well as MySQL database on Kubernetes cluster. Yeah. Do you run it or not? I don't know. It depends on the situation, but Kubernetes is very well supporting databases on containers. You can orchestrate that on Kubernetes cluster. Yeah. Hopefully, I was able to address your question, Shenif. Another one from anonymous attendee. Does this master and worker node are on different physical servers? They can be physical servers. They can be virtual servers. It really doesn't matter, but they are different, but they are isolated. Yeah. What is the use case of having DBs containerized? Again, an interesting question. I've seen a lot of companies now going, including, I'll not say names of those companies, but the environments that I've seen have pretty much containerized databases as well. So that, again, they save licenses, they save on computing power, they don't have to allocate the entire CPU and memory or do the budgeting for the entire services. So yeah, that's why databases are containerized, just like applications. Right, Binu? Okay, I don't know. A lot of these questions, okay, they are dismissed. Okay. But there is one open question that's also dismissed. Okay. How to be part of Whizlabs 100 Days Cloud Challenge? So that's a Whizlabs thing. Okay, looks like the deployment is completed as you see on the screen. I'll click on go to resource and connect to this cluster. There's a command called as connect here, and then I will run these commands. Just copy that and paste it. Where is the paste command? Control V. Okay, it doesn't work. So paste. Okay, and then this command says get credentials. Again, connect to my cluster, because there could be a lot of clusters running in your environment. So when you run kubectl apply command, so when you run this command kubectl apply, you need to know which cluster are you running it against, right? So that's why I'm connecting to that particular cluster called as Happy Saturday, and it got connected. Now it's the time I can run kubectl apply. So I will copy kubectl apply. And remember that my file name is different. It's not azure-vote.yaml. I forgot what my file name is. ls, it's called as app, I think, apps, yeah. So all I have to do is kubectl apply, and then the file name is apps. Hit enter. Now what is it doing? It's creating that cluster for you. It's executing everything that's right inside this YAML file, creating the front end for you, creating the back end for you, connecting the front end with the back end, creating the load balancer, connecting the load balancer to the front end, exposing your application on port number 80, exposing the application on 6379 to the front end is what it's doing. And it is done. It's finished. Right? So now successfully your web application is created. Yeah. Okay, so now we need to get the IP address of this guy. There's a command here called get service. Just copy that and run it, paste, hit enter. So that's the public IP. What I'm gonna do is copy this. Copy, and I'm just trying to find the chat again. Where's my Zoom? Okay, it's right here. Okay, chat. No, chat. Okay. So I put the public IP in the chat while I try to access it myself to see if it works. There you go. So I've got the web application running on Kubernetes. Now, so you see that it's all governed by the YAML file. What you write in YAML file is what you will get. Yeah. Okay, so that's what it is about the Kubernetes as well. And the way I started the presentation was with buzzwords. You know that buzzwords are all around us, but it's important to know which buzzword do you want to make as your career, right? There are tons of them. It's important to know them, know what's going on around your world, but what is it that you're really passionate about? I also said that in IT, we are prone to use them. We use buzzwords left and right now. And we have fallen in love with all of these new architectures, new design, new tools, containers, Kubernetes, and there will be new ones coming up as well in future. Every idea, there will be new ideas, and cloud has enabled people like you and me to put that idea out onto the internet and let people see it. And we use those buzzwords. These buzzwords are fueling the economy, fueling the marketing world as well. Every technology has become a buzzword, but which one do you want to make it as your career, and which one do you just want to learn to ensure that you are in pace, to ensure that you are in your journey of your IT world, right? With that, I conclude the session. I don't want to eat up too much of your time from the precious Saturday. Thank you all for your attendance and also extending by 15 minutes. Much appreciated. Also thank Whizlab team for organizing this. You have been wonderful.
It's our pleasure, Anand. We are really honored to have you for this.
Thank you.
Okay, I think it's if you want to cover any more questions, you can. Otherwise, we can proceed for the quiz, which I'm sure many of them are waiting for.
Sure. There are a couple of questions that are there in the open section. It says, how does the pod communicate? Remember, in one of the sections in the Kubernetes architecture, I mentioned kube-proxy, right? That's responsible for communication, inter-pod communication and inter-container communication, and how it's exposed out to the external world, right? Kube-proxy is what does it. Jagrut, another question, is there a visual portal to see the number of pods and it's internal from Azure or Azure CLI? Yes, absolutely. So you can just say kubectl get pods. And you see there are 2 pods running. You can see kubectl get service. And you'll be able to see all the IP addresses. You can also see this via the user interface, UI. It should be available, the number of workloads, the namespace, namespaces that are there, the services, what's exposed, and what port are they exposed. So it's all available via the user interface. But if you are a Kubernetes ninja, or if you want to become a Kubernetes ninja, I mentioned that your friend is kubectl. The question from Aditya, in this use case, we have seen that backend is Redis cache. So are we maintaining the backend Redis in private VPC? I think you are coming from an AWS background, Aditya. In Azure, it's called as VNet. VPCs are called as VNets. So yes, they are maintained in a private virtual network. Let me show that to you. So if we go to the networking section, it's called as virtual networks. You see there is a network automatically created by Kubernetes cluster. And this is where your worker nodes are created. And that's where they are getting the IP addresses from. So these are the 3 worker nodes, and that's how their IP addresses are, right? Yeah, in the private subnets as well. So of course, network subnet, that's how it is. So I hope I was able to address as many questions I could. I hope I could do demo and justify your time as well.
Great. Okay, so Anand, can you please share the quiz slides?
Okay. Quiz slides. Okay. So get set go Kubernetes. This was about the lab, and I really love this Go thing here because the entire Kubernetes model is designed around the Go programming language, Golang, which is made by who else? Google. So if you heard of Pokemon Go, yeah, have you played the game Pokemon Go? That's also made around uh, Go language and hosted on Kubernetes clusters, by the way. All right, so Q&A, ladies and gentlemen, we got 5 winners as well. Okay. I would like Whizlabs
Yes.
to explain this probably. Yeah.
Yes. Before we start with the questions, let me disclose the prizes for you so you all can feel motivated to answer the questions. So we will have 5 questions and 5 winners as well. All these 5 winners will have a chance to win 1 free Whizlabs course or practice test of their own choice. Then we have a flat 60% off coupon code, which is specially named with Anand's name. So it is with Anand 60. You get a 60% off on all our courses and practice tests. So I see some of you have asked about our courses. So there you go. You can use this code. Then we have a flat 30% off on Whizlab subscription. Feel free to use that code as well. That is Wiz Anand 30. Yes, so that's about the prizes. Okay, Anand, you can move ahead with the quiz.
And the consolation prize is the Lego.
Please make sure your kid does not trouble you for that.
Yeah. Okay, first question.
Okay, everyone, please answer in the Q&A box, not in the chat box. Sorry, I should have told this earlier. Please answer in the Q&A section, not in the chat box. Okay,
Good
Anand,
job,
you
guys.
can have 30 seconds per question, I guess.
Good job. Very nice. I
Yeah.
really appreciate. Okay, lovely. Okay, so the command is stop. In one of the scenarios, I did use Docker stop to stop the, when I was troubleshooting it, there were some problems. So that's when I did. Yeah, so C is the answer. Lovely. Okay, so the next one here. Kubernetes is a platform for. Okay, the answer. Please type like 2 and then answer 2A, 2B, because if it's coming in a sequence, we will not know. Yeah. So I think the answer is, yeah, like that. Govinath, correct. Thank you. So we got Kubernetes is a platform for running and scheduling container applications on a cluster, packaging softwares in containers, provisioning virtual machines, all of the above. Okay, we got 2 answers. I'll wait for one more answer. Ta-da, time up. Okay, so we got 2 answers and both of you are right. Thank you. So the next question is as follows. In Kubernetes, what is a node? There's a typo here. Yeah, a bit. Work pressure, guys. You know what I mean. Okay. 3N is active. Got 3A. Others, please. I think we got good participation with the first question. Good. 3A. Yeah. A node is a worker machine. A node is a tool for starting a Kubernetes cluster on a local machine. So B is not the answer. And C is a machine that coordinates the scheduling of containers. Scheduling of containers is not done by a node. Scheduling of containers is done by the scheduler, which is a component of Kubernetes architecture, right? So B and C are not the answers, and of course D is not the answer, right? So A would be the answer then, right? So for 3A, the fourth one, what can you deploy on Kubernetes? Okay, that's interesting. Please answer the fourth question. What can you deploy on Kubernetes? Virtual machines, system processes, containers, or load balancers? Okay, what will be the closest one? Let's say. Yeah, you're right, Sri. Yeah, you're right. Yeah. Good job. Good job. Okay, so how about the last question, guys? Let's see. Okay, what is a pod in Kubernetes and what does it do? A, B, C, D. Fifth one. Okay, answers flowing in. Very good. Fifth one. Of course, you find peace of mind there, right? So with a pod, we'll be creating peace of mind. All right. All right. Yes, you all are correct. It is D. A pat on the back and claps for everybody. Amazing. All right. The most important slide of the day. Thank you, everybody. Outstanding.
Thank you so much, everyone. So we will announce the winners on our social media. Make sure you follow us on LinkedIn, Twitter, Facebook, or Instagram, whatever you feel comfortable with. And we will be posting the winners tomorrow. So, and also be ready for the selfie, guys. I think this is one of our signature thing. This has become a trend for all our webinars. So whoever wants to be in frame with Anand, please raise your hand. We will turn you into panelists, and then you will be able to switch on your cameras.
That's
Thank you,
not the
Vijay.
case for me.
Okay, so done, right? But people are joining in now.
Yes, we are adding them as panelists.
Okay. Oh, you want to take a screenshot? Okay.
Yes.
Clear. Okay. Okay. Oh,
Nice
okay.
to see the
Lovely.
participants. Otherwise, they are the only ones seeing us.
Okay. Yeah. Good to see the faces, the answers, the faces behind the answers. All right. Okay. Devendra, Vidya, Prasoon, Aditya. Okay. Gobinath. Hey. Karthik. Valka. Rajshekar. Manu. Hey. Good hairstyle, mate.
You
Cool.
all can unmute yourself if you want any
Cool.
questions answered. You can unmute yourself now. By the time we add more people.
Yeah, hi Anand. Thank you. Thank you for the session. It was very much informative. And yeah, I'm working on the tail as well.
Lovely. Thank you for your feedback.
Okay, those who have been added but still not switched on your cameras, please do so. Okay. All right. So I think we are ready for the pictures. Make sure you are ready with your poses too. Because this will be posted on social media. So then you can't come complaining that, hey, I was not looking nice.
Hey, Dell. Hey. Okay, so I'm ready.
Okay.
All right. James, okay. Follow.
Yes, done. Thank you so much, everyone.
Thank you.
Bye-bye.
Bye. Everybody have a wonderful weekend, guys. Enjoy.
Same to you, Anand. Bye.
Ciao. Bye.
Thank you. Bye.